Hello class. As we begin chapter 9, if you remember, we already covered section 9.1. So today we'll be on 9.2. Our objective is to graph quadratic equations. This form, y equals ax squared plus bx plus c, is known as the standard form of a quadratic, the standard form. And through chapter 9, we're going to cover and look at and change from one form to another of these quadratic forms. Okay, let's review for a minute what we did in 9.1. We graphed equations of the form y equals ax squared plus c. And what we did is we used the c to move the vertex up or down. So let's make a note of this. The c moved the vertex. Remember, these all graph into parabolas. The c moved the vertex up or down from the origin, 0, 0. And then we applied the A rule. And we'll review the A rule. From the vertex, move 1 to the right and up or down A. And then we go back to the vertex, move 1 to the left and up or down A. Those are the only points that we get with the A rule, but that's enough to give us the general shape of our parabola. So let's review just sketching this parabola. So we start at 0, 0. This is our C. Since it's a -3, we will move down 1, 2, 3. There's our vertex. Our A is 2. So from the vertex, move 1 to the right and then up 2 because A is 2. And then 1 to the left, go back here, move 1 to the left and up 2. And then this is enough to give us a general shape of our parabola, just sketching it. You should be able to label these points. The vertex is the point 0, -3. If we move 1 to the right, we're at 1, comma. We moved up 2 from -3, so this would be the point 1, comma, -1. And this would be the point -1, comma, -1. So you will be responsible for naming 3 points on the parabola. Let's try one more. Our C is +1. That means that we're going to move up 1 from the origin. There's our vertex. Our A is a -3, so we move 1 to the right and then down 3, 1, 2, 3. We go back to the vertex, 1 to the left and down 3. And this parabola will be facing downwards. This is the point, 0, comma, 1. This is the point, 1, comma, looks like we're at -2. And this is the point, -1, comma, -2. Now, if you remember when we talked about this A rule is not in any math book, but it always works. One thing that we can't do is keep walking out 1, down 3, out 1, down 3, because that's what lines do. They have a constant slope. We would get a straight line. And parabolas do not have a constant slope. So we can use the A rule to the right 1 time and to the left 1 time, and then that's all that we have. Well, you might be wondering, because you've seen pictures of parabolas, they could be over here. In other words, our vertex can move to the right and the left. Well, how does that happen? Well, that happens when you have the form. Notice on these we didn't have any b terms. We didn't have a bx. We only had the a and the c, a and the c. Well, when we do have a b, we've got a new rule that we need to establish. So this is what's new in chapter 9.2, And this is something that you're gonna want to memorize. And you'll have to use this fact all through your high school math classes. All right, where is the vertex when we have a bx term? The way you find the vertex is the x-coordinate of the vertex is negative b over 2a. Where do the b and the a come from? They're going to come from your given equation up here. So the x-coordinate is negative b over 2a, and the y-coordinate is found by plugging in this x-coordinate into our quadratic equation. That might be a little confusing, but let's walk through one. Okay? We want to sketch the graph of y equals 3x squared minus 6x plus 2. Now, when you're just getting started, you might want to label these ax squared plus bx plus c. So a is 3, b is negative 6, make sure you catch the negative, and c is 2. All right, over here on the left on this post-it note, I've written these down into steps. So the very first step is you find the x-coordinate of your vertex. And what is it? It's negative b over 2a. I'm going to leave that right here. Sorry if it's a little bit clumsy. So here we go. The x-coordinate is going to be negative b. So if b is negative 6, a negative negative 6 would be a positive 6. All over 2 times a. If a is 3, 2 times 3 is 6. So our x-coordinate is 1. What is our y-coordinate? Well, now to find the y-coordinate of the vertex, we have to plug in the x-coordinate into the equation. So x is 1. I'm going to plug in a 1 for x up here. So y will be equal to 3 times 1 squared minus 6 times 1 plus 2. Let's do the order of operations. 1 squared is 1. 1 times 3 is 3. 6 times 1, 6 plus 2. So we've got 3 and 2 is 5 minus 6. This is going to equal negative 1. So our vertex, sometimes it's written like this. The vertex is at the point 1, comma, negative 1. And if I'm going too fast, you might want to rewind the video and watch this over again. Okay, so now our steps, we found our x-coordinate, we found our y-coordinate, now we know where the vertex is, and then we just apply the A rule, and we can sketch our parabola. So we go to the point 1, comma, negative 1. There's our vertex. Go back up to our original equation. Our A is 3. The A rule still works. But notice we're going 1 to the right and up 3. 1, 2, 3. And 1 to the left and up 3. And this is a sketch of our parabola. Just make your point bigger if your line doesn't go through it. Here we go. Can you label these points? Well, of course, we have this point is 1, comma, negative 1. This point would be 2, comma, 2. And this point would be 0, comma, 2. Remember that parabolas are symmetric, correct? And so these points are going to be positioned symmetrically from each other. All right. Here's another little tool for your tool belt to make sure that you graph this right. The C is always the y-intercept. The C is always going to be the y-intercept. Notice that our C is 2, and notice that's our y-intercept. So that's one check that you can use. Make sure that you're doing your math okay. If you sketch your graph and your C is not the y-intercept, then you've done something wrong. Okay, let's do another one. We're going to sketch a graph of y equals negative 2x squared plus 12x minus 7. All right, if you want to label your A, your B, and your C. All right, the first step is to find, move this up here, find the x-coordinate of the vertex, which is negative b over 2a. So x is equal to negative b, so it'd be a negative 12 all over 2 times a. So we have negative 12 all over negative 4, positive 3. The second step, find the y-coordinate of the vertex by plugging in this x that you just found into your quadratic. So y is equal to negative 2 times 3 squared plus 12 times 3 minus 7. Just plug this in right here. Do our PEMDAS, so let's square this first. 9 times negative 2 is negative 18. 12 times 3 is 36 minus 7. So I've got a negative 25 and a positive 36. Is that 11? I don't have you here to catch my math mistakes. I'm hoping that's 11. So we've just found our vertex. Our vertex is the point 3, 11. Well, looks like I might have to go by 2's over here to get this in. 4, 6, 8, 10, 12. So 3, 1, 2, 3, 11 would be up here. And then now our third point is to use the A rule. So our A is negative 2. From the vertex, go 1 to the right and down 2. And since I'm going by 2's, I'm just going to have to guess at it. And then go back to the vertex, 1 to the left and down 2. Sketch your, oh, okay. Wow, look at our C. Our C is at negative 7. That's going to help me out. I'm not going to flare this guy out here. This guy has to cross the y-intercept at negative 7. So here's negative 2, negative 4, negative 6. Here's negative 7. Let's see if I can get it. And that just helps me a little bit to be more specific. Okay, so right here is the point 0, negative 7. Here's our vertex, 3, 11. 1 to the right would be 4, down 2 would be 4, 9. Back would be 2, 9. Notice that for these 2 points, your y-intercept is going to be the same. So this is the point 2, 9 right here. Now what's very interesting is we can find out what this point is by using symmetry. And I just want to show this to you because it helps to kind of enrich our knowledge. From 2, 9, we went back 2 more, correct? And then down 16. Well, we know this is going to be a negative 7 over here. So from here we went back 2. So from 4, what can you guess the coordinates of this point would be? Did you guess 6, negative 7? Okay, and I challenge you to put in 6 up here. You should get a y is equal to negative 7. All of these shortcuts that I'm showing you are to save you from doing a t-chart. If you look in your book, they're going to give you a X and Y, and listing values, right? Which is just kind of a drag. So we just kind of want to save ourselves from this. Being able to sketch this graph is really important, and you'll use this skill right through calculus, graph sketching. Okay, a couple of important things that we need to know about our parabolas are, do they have a minimum or a maximum value? Very important. If you're watching the news, especially, you're looking at lots of like flattening the curve and lots and lots of math and lots of modeling going on with science, of course, and probability. But to find out where the minimum or the maximum occurs is very important in lots of applications in real life. Heights of things, business, that when you're talking about income, where do things maximize the income, and etc. So let's take a look at this parabola. This parabola points downward. How do we know that it points downward? Because our A is negative. So our vertex here, our vertex, which is 311, is going to be a maximum. What is the maximum value of this function? It would be 11. The y is the maximum value. Where does it occur? It occurs when x is at 3. Let's go to our previous parabola. This parabola opens up because a is positive. So what is our min or our max? Well, it has no max. It keeps going and going. So the vertex here would be the minimum value. So here the vertex is a minimum. What is the minimum value of this function? It is -1. Where does it occur? It occurs when x is equal to 1. So each parabola has a minimum or a maximum value. It's not going to have both. So this always occurs at the vertex. So some of your homework problems just say, find the minimum or the maximum value. So what are you going to do? You're going to look at the A and determine, is the vertex a min or a max? Again, if A is negative, the vertex is a maximum. If A is positive, the vertex will be the minimum. What is the min or max? You're going to have to find the vertex using this -b over 2a and plugging it in. Okay, another important fact to know about parabolas are domain and range. Remember, the domain is the x. Well, do all of the x's eventually get covered? Or algebraically, is there anything x cannot be? And the answer is no. So the domain for parabolas is going to always be x can equal all real numbers, always. Now the range is going to depend on, does your parabola, remember the range is the y. If a parabola points down, your range would be y is less than or equal to the maximum value. So the range for this parabola would be y is less than or equal to 11. That's the range. For the previous parabola, domain, again, x equals all real numbers. The range, y is going to be greater than a -1. Greater than, or equal to a -1. Domain and range. Another item that your book covers, and if you're looking in your book, you'll notice that I'm doing things a little bit different than the book, but the book may ask you, what is the axis of symmetry? Well, all parabolas are symmetric. And if you were to cut them in two so that one side could flip over on the other, notice that the line of symmetry is going to go right through your vertex, correct? Also notice that this line is vertical. That means it goes up and down. Vertical line equations have the equation of x equals. So your axis of symmetry is always going to be x equal, and it's going to go through the x coordinate of your vertex. So x is equal to, we know that's negative b over 2a. That would be your axis of symmetry. And it's the same if your parabola goes up or if it goes down. So the axis of symmetry here would be x equals 1. That's called your axis of symmetry. And truthfully, this is something that you don't really use that much in higher level math, but whatever. All right, a couple more examples from your book. Find the minimum or maximum value of this. Notice we don't have to sketch it. Yay! We only have to find the minimum or maximum value. So this is what I'm going to look at. We're going to look at the A. A is negative, so our parabola points down. So our vertex is going to be the maximum. So it has no minimum, it has a maximum value. What is the vertex? X is equal to negative b, which will be a positive 12, all over 2a, negative 6. Now that's where the maximum occurs, but I don't know what the max is. What is the max? It's the value of this function. So I'm finding f of negative 2. Don't get freaked out about this. F of x is the same as y. This just shows I'm plugging in negative 2 for x. Different notation. So I've got a negative 2. Ooh, I gotta square that. Let me show you what I'm gonna do. Double parentheses. So I remember to square the negative 2, which you know is gonna be a positive 4. I might as well do that. 4 times negative 3, negative 12. All right, but I'm going to continue. Negative 12 times negative 2. That's a positive 24. And then plus 10. I kind of wrote that out a little bit goofy, but so this is positive 12 and 10 more is 22. That's the y. So the maximum occurs at negative 2, the max of the value of the function is 22. This is our max. Alrighty. Example 4 in your book is a real world problem. Let me look at this. This is on page 579. Page 579. And it shows a bridge. Actually, it's the Mackinac Bridge. And they want to know what is the height of this cable. This cable is sagging. Here's an equation that represents the cable. What's its height at its lowest point? Do you see how the A is positive here? So we know that this function is going to have a minimum. What is the minimum? Well, we are just going to go x is equal to negative b. So since b is negative, negative makes positive, 0.37 all over twice a. And you know what? I forgot to bring my little calculadora out with me. So I'm not going to finish this guy up, but you're going to get a value. Then you're going to plug that in and find your y value, which will be your minimum. A little bit difficult to crunch those numbers, but a very useful way of seeing how this is applied in real life. Okay, here is your homework. If you have any questions, just drop me a chat on the chat line. Take care.